Today, most of our city traffic network is based on traffic lights, roundabouts. During the rush hours, busy intersections can easily get jammed and quickly spread across the whole area or even most of the city. There is a better way to solve this traffic problem. Loop-based design will remove the need to cause any conflicts between vehicles. This introduces a new concept in city traffic, continuously flowing. No matter how busy the traffic is, such kind of intersection will never become the bottleneck of the traffic. All the vehicles can quickly pass through the intersection, without any need to stop or even slow down. Because the traffic is flowing and no vehicles need to stop and wait for a traffic light to turn green, the carbon emission is greatly reduced. In most of the cities, a common way to construct the road around an area is to use straight roads to surround the area like this. It is widely adopted, so everyone will assume this is the way to build our cities and roads. Today, we will introduce a new way to construct our cities and later share how this new design will benefit us to embrace the future autonomous driving, reduce gas emission and improve the safety at intersections. The basic building block of the new route design is a one-way loop. The one-way loop is a closed route that only allows traffic with a certain speed limit going in one direction. What you are seeing here is a clockwise loop. A loop can also be counterclockwise. There are only these two options, either clockwise or counterclockwise. When we put these two loops in one screen, we can easily see that one adjacent edges of both loops are flowing in the same direction. How about moving them close to each other? The highlighted rectangle area will now allow the traffic flowing from one loop into another. Now let's put a dotted line at the adjacent edge of these two loops, to indicate that cars can move from one loop to the other, by changing lane. Please note that in order to do this, both traffic must be in same direction and these two loops must beside each other. When four loops are arranged close to each other like this, a vehicle can start from any point of any loop and arrive at any point in another loop. For this example, we add dotted line to show the case of two-lane situation. If a loop contain only one lane or multiple lanes, the concept will still stand same. Let's assume a car need to move from point A to point B. It starts from the top left loop, then move to the area that adjacent to the top right loop. Because the traffic directions are same, the car can simply change the lane and get on to the loop on the right side. It is important for the vehicle to follow the same lane during the turn. Then get onto the lower loop by changing the lane again. After that, just follow the lane to get to the point B. Now let's expand this loop concept to simulate a small city area. Assume you will need to commute between points A and B regularly. What will your experience look like? Firstly, the traffic is continuously flowing at steady speed. So you can enjoy a very predictable arrival time every day. That means, if the total distance is 10 kilometers, and your average speed is 60 kilometers per hour, then you can expect 10-minute travel time every day, no matter is rush hour or at midnight. The green box area shown in the diagram used to be the bottlenecks of our city road network. Now they are continuously flowing well and generates zero vehicle conflicts. When designing the intersections for traffic, the safety is always the most important factor. We will compare the safety facts of this new design against the traditional intersection first. Then look at the continuous flow feature that will benefit the throughput of the whole city.
Conflicts of four-way intersection. A standard four-way intersection controlled by traffic lights contains 32 vehicle conflicts in total. There are 8 merge conflicts, 8 diverge conflict and 16 crossing conflicts.
Now let's take a look at the loop design. Because vehicles get on target loop by changing lanes, they must stay in their lane at the intersection area to complete the designated turns, either to the left or to the right. This will avoid all types of the conflicts, including cross, diverge and merge. Traffic-controlled intersection can be slowed down or jammed for many reasons. Here we take a look at some commonly seen issues that can block traffic or generate inefficiencies. Even facing a green light, a left-turning traffic can be blocked by heavy incoming traffic. While this left-turning car waiting for the gap to make the turn, the following straight-through traffic can be blocked for the whole green period. Such jam can quickly spread the chain reaction to multiple adjacent intersections during rush hours, causing traffic jam in wider areas. Traffic accidents caused by vehicle conflicts are also the key reasons causing the traffic jam and inefficiency. Continuous flowing design. Because a car no longer need to wait for a green light to proceed at intersection, it can proceed at the speed limit at all time. That means when crossing the intersection, drivers no longer need to slow down, observe and read the road condition. The traffic is changed to a continuous flowing mode. The throughput of the intersection is now at least doubled, because all the vehicles are continuously moving in and out of the intersection, without any slow down or stop. When we apply this to a bigger picture of the city, the traffic of the city will be always flowing. Intersection of the busy areas will no longer become the bottleneck spreading the traffic jam across the city. Thanks for watching.